Rajan. Welcome to the Agile Podcast. So we're going to talk a little bit today about how research basically creates value within a city. Obviously, you as a professor, long-standing professor in university, you know obviously what teaching, obviously how important that is, but also how universities can be a value creator within the local universities. So if you want to just start with a bit of an introduction to yourself and what you've done and what you're doing with us.
Right. So thank you, Raj, for having me on this podcast. I'm feeling really happy to be here. I am Rajan Tripathi. I've been working as a professor with MIT University in Tashkent. My area of specialty is machine learning in the healthcare domain. My PhD has been in the breast cancer, the application of machine learning in prognosis and prediction of cancer. So as a person, I always try to blend the research and the industrial perspective of the research. So in that step, I am happy to be associated with Bikal recently, where we are working in cutting edge technology. So some of the products I would like to mention here, which we are working on, like the Convoy AI product to manage the fleet and the convoy, the micro radar system for drones, which helps them in better navigation and surveillance. Recently, we were also working on that lensless holography. It's a modern, or it's a little step aside from the traditional microscopy. Takes in the high resolution cellular image. Also, we are working on the crash for cash, identifying the fraudulent motor insurance, and many more. So really happy doing that, integrating research, academic research into the viable products and improving the product in that technological readiness level along the way. So that's what we are doing here.
Thanks. So basically, the idea of today is like I said, just to sort of create a bit of a discussion around how research is valuable to a local economy. Traditionally, it's always been thought of that defence or military spending is where all the ideas come from, right? So the World Wide Web came from DARPA, right? The defence arm of the US military, if you like. And obviously since then, lots of innovations have come from military, but that's not always been the case. Obviously, universities historically have been pillars of a local community, and some unknown places to the modern world, as where this is, there were historical locations where research was taking place. Some of which you speak about, right?
Right. So yeah, definitely I agree on to that military spendings or the military aid has always fostered the innovation. Rightly said, the internet as the ARPANET project, and for example, the jet engines. Those were developed during the World War. In fact, during the World War II era, most of the significant research we saw, which we are leveraging today. Jet engines, both the Axis and the satellite powers, they invested heavily in those. Then radars, satellites. In fact, even the computational power or the computational machines were generated during that time, were made during that time to calculate the artillery firing table. And from there, it builds on. Even the drones were used for the military surveillance, and now we are using drones in our area. So definitely, so military, and then of course the infamous Manhattan Project for the nuclear. Also, so World War, unfortunately or fortunately, helped in technological innovation, right? But yes, it was not always the case. For example, back in the 5th century AD, if we talk about, In India, the university Nalanda University was there. Uh, it ran for almost 500, 600 years, and this university was not just an educational institute, rather it was an innovation hub of this side of the world. In fact, the whole Buddhist country, if in today's India, China, Korea, Japan, and your Central Asia, Indonesia was the part of this circuit. Uh, it is believed, and there are some documents as well, that during that time the medicine was really advanced. They knew how to do the surgery. They knew how to do the nose rhinoplasty, the nose surgery. We have access to documents which shows that the drawings of around more than 100 surgical equipments they had hundreds and thousands of manuscript, and all those were written on the palm leaves. So the printing press was not invented by that time. It was very difficult to write in the farming, and like this they had hundreds and thousands of manuscript. If you will read more about it, they had a very, very big library full of these manuscripts and pertaining to different curriculums: medicine, maths, logic, astronomy, theology, and much more. So yes. So if we talk about the military, so military was responsible for destruction of this long-standing institution, isn't it? In the 12th century, Bhakti or Khilji, when he attacked India, so he made sure to burn the library. Now it could be a political, religious, or economic reason. We don't want to get into that. But the thing is that he burned, and legend says that it burned for months or perhaps years. It was so big because it was palm leaves, so it was just so vast knowledge was lost into the flames. Why? Because at that time we were not having the access of redundancy, access of storing the documents or the information into separate. So if it's burned, it's gone. So military can foster innovation, but the same military can destruct the innovation. Maybe, for example, we are in a state of war in some places of the world. The rockets don't identify the educational institutions and military.
The people as well. And the people as well, unfortunately. That makes sense. But that's a good example, isn't it, as well, where, if you look at the sort of centres in the world today, you look at Oxford or Harvard or Stanford, but we think that these were the long-term history of where obviously academic research has always been. But if you look back, beyond our sort of lives from before, there's all these other places, obviously Baghdad and House of Wisdom. There's many areas around the world that have high levels of research. So I think obviously research, it can be done anywhere. I think that's one of the things that we sort of agree. That there's obviously ecosystems and there's ideas behind this. Maybe the research processes haven't changed that much, but the research, how it's stored and saved, and obviously, like I say, how it's continued, obviously has changed. And so, in terms of obviously, like you say, that redundancy side of it now, I guess that helps, places around the world now, not only to work on their projects, but to access other ones as well, right?
Right. Of course. So, I rightly said, there's Oxford, Harvard, Stanford, established in 12th and 19th, 17th century respectively. So they are actually the pillars of innovation of the West. So the dynamic change from east to west. So again, I want to talk more on that. But yes, universities are responsible, and I think the Industrial Revolution stands on the shoulder of these universities. And now the education 4.0 and all these things. So yeah, I'm talking about the redundancy now. Thankfully, we have cloud technologies now, so we can store the information online, and we can also have backup And not only at one place, we can have backup at several geographical locations. So even if one place is lost, basically the information now is forever.
Right.
You cannot lose the information. Plus, during the last 5 or let's say 10-15 years, we are seeing the rise of open source technology, open source journals, massive online open courses, MOOC, we call it in short. These have really helped in democratizing the knowledge. Earlier, if we talk about the Nalanda or Takshila University, so whatever the information was there, it was local. Before this cloud computing or this open source technology, whatever the research of Oxford, or let's say West, it remained in West. Localization of information was there. But now, because of the rise of this open source community and the technology, this democratization of knowledge has occurred, and irrespective of socio-economic status of a person, they can access the information. It really helps in accelerating the innovation, because a idea can come to anyone. It should not be just West or East or something. So with that, it really has helped. And with AI now since we have cloud and we have a lot of information available with us, what to do? Like 10-15 years back, we had information, of course, with sensory data and all the social media and everything. So and basically information is everywhere. But with the rise of AI, and I will also say with our ability to compute large source of data, or the large portion of data with the high computing environments, now we are able to shift through a high amount of data and can get meaningful information out of it. Otherwise, any unstructured data or some structured data is just a piece of junk. But to identify meaningful information, some meaningful patterns out of it, so this has really helped nowadays, and especially in the last decade, in really accelerating the innovation in today's landscape.
So that's interesting. Yeah. So as we said at the beginning, you are the TRL3 and we are the TRL4, right?
Right.
We're the ones that leverage your skill to. So as a company, we don't really ideate, right? We don't really have the ideas. We may bring you challenge statements that already exist. Right. There's no ideation on our side. Some technical ideation in terms of deployment and things like that. But in terms of, like you said, you mentioned obviously being able to connect to people and be able to find information, that's obviously different. Is there a change? Have you seen a change in terms of which PhDs are done? Is there a faster pace now? Are you able to do something quicker, move on to the next idea? Are you able to cross-pollinate ideas? Has that been a change in your timeline as a professor?
Right. So see, if we talk about the PhD, the basic trajectory of a PhD revolves around collecting data, doing some complex computation, analyzing data, simulation, right? All these things are the basic trajectory of a PhD, and it takes usually around years to do this and reach to a conclusion. With the use of HPC, high performance computing, and access to these tools, it has definitely reduced the time span. For instance, let's say that since I belong to the health domain of the machine learning, so genomic studies are really important to identify the sequence and analyze the genome. Why it is important? Because, for example, I work on the breast cancer patients. So in a breast cancer, the same kind of treatment plan for one cancer patient might or might not work as effectively on the other patient. What is the reason behind it? Is the genes, right? So you need to understand the genes, and genes are very complicated things to analyze, the whole DNA pattern and all. It used to take weeks or months to analyze. It was a daunting task. Now, if you have access to high performance computing, the same task can be done in hours. So it really helps you in identifying what is the nature of the gene. You can predict the outcome, how they will behave with that sort of this the interaction between different genes. And you can also, other domain also you can use. For example, in health, if we talk about health one more time, so we also use a 3D imaging, so 3D MRIs, 3D CT scan, 3D ultrasounds. But these 3D images are very heavy. So it talks about hundreds of MB, and if you have like 100, 200, 500 of such data, it takes up like hundreds of GBs of space. Sometimes you need computational power. Without that, you will not be. Earlier, it was not possible to actually analyze them, right? So has helped in that domain as well. If nowadays, if you are into you want to behave how the climate is changing, you can basically create a climate model, maybe run a planetary behavioral analysis of years or decades of data, and you can reach to a conclusion. So you have this leverage. You can leverage this new thing, and now you, as a PhD student, if I talk about, now you don't have to be afraid of, because when you start a PhD, first thing which comes to your mind, whether I will be able to finish it or not. So of course, because it requires a lot of years. It's not the money, it's the time which is at the stake here. So it's first fear among all the scholars: should I take a light project? Should I take a hard project? So now with the help of this technology, they can punch above their weight. They can think of that. They can.
So you're saying that the idea can be more risky? Is that what you're saying?
They can, yeah. They can actually push the boundaries of the research which they already have, and that's what PhD is all about. There's a circle, there's a boundary of a research, and each PhD should increase that boundary a little bit. Right. So that's what a PhD or a good research is. So these tools basically help you in pushing that boundary. So this time has really changed. You are not afraid of taking risks. So it's good for science.
Yeah. So for industry and government, they can obviously play a part in this. Not only are they creating, like, so for instance, I'm sitting in the Sharjah research park. Obviously in Uzbekistan, we have the IT park, we have the techno park in Coventry we're associated with as well. So you have these hubs, which obviously are they're created by national and local government. But that's not the only part that they can play or industry can play. The idea, like you said, is that historical data. Before, it would be, like you say, something where it might be a small change to someone's an idea might be quite small because the PhD doesn't want to take a risk. Now they're in a position where they can take a bigger risk, as long as the government or the industry give data. It doesn't cost as much time. It's not a 3-4 year project. With HPC, you can get some initial results quite quickly.
Definitely. So yeah, data is I tell you one more example in this case. In our artificial intelligence and machine learning domain, AI, attention model or something which is really popular. So those who are into AI, they know about it. So how it builds on. So in 2015, this attention model first came in the University of Montreal. It was a part of a PhD. 2015, so they were making the machine translation. So it was just a step up from the long short-term memory and the recurrent neural networks. From 2015, just in 2 years, in 2017, in Google Brain Lab, they enhanced it. This attention mechanism. Now it could focus more on the inputs, on the parts of input which are more important, with reference to the context of the output.
Right.
So, for example, in ChatGPT, when we type something, it doesn't give you out of the context answer. So yes. So GPT is a generative pre-trained transformer. So this transformer key component is the attention model, which came from that attention research which was done in 2015, enhanced by the if we talk about the Google Brain, it has billions of funding to pump into any technology sitting on cash. Uh, Now, this attention model with created the transformer. Transformer created the large language models. Large language models is like one of the prime example is Chat GPT and others, Llama and all. So this GPT now is shaping different industry like computer vision problem, NLP problem, speech recognition, autonomous driving, robotics, finance, and and you name the industry, and we are using it. So of course, so the government or the industries, they have to jump in to give the data to enhance the technology, right? So if we talk about the TRL level, so TRL3 was the research at the university, and and basically it's just the proof of concept. I will, in a simple words, I'll tell like it is like you are having a recipe which you think will work because you have seen other similar kinds of recipes solving similar kinds of problem, but and you have a controlled environment where you are testing it in your computer or in a facility in which university has given you, and you have then published the paper, and you think it can solve. But this from this thinking part, you should go to the industry people, which they validate this concept, and they make try to create a viable product. And if we talk in terms of that, so they create a dish out of this recipe, they taste it, and then they decide whether it to be included into a restaurant or not.
Or it might be changed a little bit, right? Because obviously the customer
Might change a little bit, or because the whole market dynamics, the user friendliness, the cost effectiveness, the researchers they cannot sometimes it's a daunting task for them to understand this. So that's where the industry and the governments they need to come in and then to enhance that research method.
So what's been happening in the UAE? There's an organisation we're working with, TII, Technology Innovation Institute, based in Abu Dhabi. They come under the Advanced Research Technology Council, and so we're basically working with them where they will take the TRL. They're almost like a TRL 3.5. So what they're able to do is they're able to take the research, do the applied sort of validation almost, I would say, when they're going to research further. And then we're on the other side where we have the customer engagements, and we will give them the access to data. So the organizations that we work with in the UAE, we will tell them, say, look, TII are there, can we work with them? So we should be hopefully agreeing on some of these models with them next week. And I think, going back to what you said about Montreal University, hopefully they registered their IP, because obviously that's going to be important. But it shows as well, doesn't it? I mean, as long as having research and then controlling it in an environment and then not giving it to anyone, you have to release it. But what that will do for someone like Montreal, I would suspect, and you can expand on this, is it will attract other academic brains. The fact that they've had a success story, the fact that it's being used, and also I think within the Canadian government will potentially invest more into them, right?
Yeah, of course. I mean, why not? For example, if you are creating a research or a solution to a problem, so definitely. So one aspect is the financial side of it. So you invest in a product. That product works. It solves some problem. That product sales in certain quantity, and you get the money. It's not always about the money which you earn from there. So it basically creates a ripple of the good things. For example, if let's talk about a project, for example, a telemedicine project. So an academician with the help of a team of medical researchers plus faculties plus other academicians, they develop a software for telemedicine, and let's say that this software will have some features like online consultation, some AI diagnostics, and it may also have some algorithm which takes on the data from the wearable device, the like the smartwatch,
Yeah.
And they have this algorithm created in, just like in the University of Montreal, they created this mechanism, attention mechanism. So they create this algorithm for telemedicine. That's TRL3. So they created this algorithm, and they think that it works fine. But at this level, the software might not be robust, might not be very user friendly. Then comes in the industry. So industry, it can come up with maybe money, most importantly, infrastructure and the resources which they have. So they come in between. They create the robust software. They make it user friendly. They pump in a little bit of money or something like a wearable devices. They also help in distribution of this software to the hospitals, to the clinics, to the private practitioners. They also take care of the regulatory compliances, because as a researcher, they are not expert on this. They're computer scientists. They don't have expertise in the healthcare regulation. So the industry, they have the resources. They can come in. Government can also, first of all, government should be receptive. Government should be open for such kind of development. They should feel that there is a need of this thing. They should release funds, because of course monetary should be there. They should release research funds for the university, for the industry, maybe to collaborate together. Then they help in deployment of this hospital, of this software in the hospital, in the suburban or the rural areas. And let's say that it works fine. Maybe it generates a lot of money, maybe it doesn't generate a lot of money, but if this implementation is doing really well, the amount of problem it can solve in terms of society, your rural population or suburban population is getting the best health facility.
Right.
The cost of travel and visit to the hospital or the doctor is drastically reduced. The whole healthcare system is robust now. With a healthy population, the government can generate more money, tangibly, intangibly, and I mean, wealth lies with the health, isn't it? So,
Right.
It's not only always about the money. So, of course, if this one model is successful, it will help the government. It will be like a magnet. The government will look for different universities, different partner. It will open 10 other types of projects simultaneously. Do this. Even out of those 20 projects, even if 10% huge success rate is there, we create some unicorns or creating some bigger problems. It basically helps the local government to generate more income or to solve better problems. It basically it's like a magnet for newer companies to come in, because now you are an innovation hub. That town becomes an innovation hub. So in that respect, research definitely brings in a lot of good things. But yes, a researcher alone dies because the TR level 3, so you don't have the validation of this, so it doesn't go to the product stage. A researcher with the help of industry, with proper funding, proper remuneration, it always helps in growing up. That's what we are seeing in the Silicon Valley, isn't it?
That's right. So there's a spawning effect, isn't it? That the companies and the universities, they're very much tied in with each other. And like I say, there's other places in the world now where I think localization is taking place. They don't want the brain drain to happen. They want to keep especially the smart people to be, if someone's had 15, 16, 18 years of schooling locally, and then they take a university abroad, and they've lost that person, haven't they? Which is always a bit of a shame for them, especially in some parts of the world. But like I say, the world is changing. So now that I think you've painted a good picture, in the sense that research is a bit different. There's more tools available, there's more avenues available. I think from our side, we're facilitating as we speak, especially what we're going to announce next week. Hamad Al Wahadi, who's our first UAE tech transfer student who's going to basically develop his product with us, with our help. What would you say, in a closing message, what would you say to somebody who's finished their degree, and they're at that crossroads? Do they go and get a job, or do they do some more research? What would you say to them is perhaps different to when you probably started your PhD early on? Oh, sorry, when you were graduating as well.
Very interesting question. It is. So I'm a teacher. I see thousands of students every day. So see, each individual will not have the same bent of mind. Someone will be good in research, someone will be good in coding, someone will be good in other things, right? So research, it requires discipline. It requires you should have some drive to be into it, because research, you have to get stuck into one problem, and you should have a research bent of mind. That research acumen might not be present with everyone. So if you think that you have the research acumen, you must. And if you think that you have developed a product which you think can solve some problem, you should not leave it. But I will not say that everyone will go into research, because then who will be going in the IT or industry to do other work. So you cannot just go in one direction, everyone. We need all sorts of people. We need the implementers, we need thinkers, we need a whole bunch of that. So if you are a PhD graduate, you have the work. My message will be, just don't sit with your degree. If you are just a recent graduate, you have created a product, find someone who can help you in going from that TRL level 3, the proof of concept, to actual making that product. And that's what, see, it might take a little bit more time, but I really want to touch upon this fact that I'm seeing in the industry, in the academia, the focus has been on publishing a lot of research paper. That publishing part has really taken the front seat, and the quality of the product which is made from that research has been really taken up a back seat. So we should change the role here. We should do a meaningful research, and it's a message to all the young researchers. Don't go after the numbers of the amount of papers you have, but do one work and be good at it. Try to solve a problem which can impact the whole society as a whole. And naturally, if you are able to solve a problem for 100,000 people, or even for 5 people, doesn't matter. That product is bound to be a hit. That product will give you what you want in terms of recognition, money, or something. You just have to be honest there. Just don't do just for the sake of numbers. The world has changed with the LLM, Chat GPT, and all. The writing documents is not very difficult now. Use that, leverage this technology to create a product. Product is important here to solve some problem. That is my message to the young researchers out there.
All right, okay. No, that's interesting. I mean, with the way technology is these days, and the ability to access in some places certain value, you can experiment very quickly. And you can fail a lot faster as well. That's the one good advantage we have these days.
That's good for you.
Yeah. So look, the idea is, thanks for the time today. What we'll do is, like I said, I think we'll have a series of these. Right. As we start discussing on each particular project, it's important to have someone from the university side discussing it and talking about tech transfer, and obviously the points that you made today. I think they will carry on through, and we'll be able to show the audience how we actually evolve into something. So thank you for today.
Thank you. It's really a pleasure talking to you on this subject. Looking forward for more such talks. Thank you.